Hey everybody, in this video we are going to be focusing on simplifying powers of I. I did reference this in the multiplying complex number video that I would get to the larger powers and the nitty-gritty of that over here, and here we are. So I mentioned a couple times already that I is only allowed to be written to the first power. It cannot be in a denominator. It cannot be raised to a power other than 1. So we need to take care of that before we can be done with the problem and fully cleaned up and simplified, right? So what we will do is a couple ways that we can look at it, but let's try to be as efficient as we can. I'm going to get right to it. I learned the powers of I in what my teacher referred to as an I chart because they thought they were being punny, like I chart, like a vision chart versus I chart, like I, the imaginary number. But to me, it makes no sense to put something like that on a table, in a table, because the numbers are cyclic. And anytime something is cyclic, we should put it on a circle. For example, a clock. Doesn't it make more sense that time goes on a clock? Because we see those same hours go round and round. Why are we going to make a scroll of such a thing when it could be put on a circle, a wheel, whatever you want to call it, right? So I like to put this way. Now I'm just going to name a couple things for us over here. In red, okay? This is all going to tie together with other stuff later as well. In red will be my imaginary axis, and my imaginary axis will have a positive end and a negative end, just like what we're used to. So my imaginary axis is going to be vertical. It goes up and down, okay? And the one end is positive, right? And one end is negative. And since it's imaginary, I'm going to have positive I and negative I on my imaginary axis, okay? Then the next thing I'm going to have is the real axis. And that real axis will be horizontal, right? And it will also have a positive and a negative end. So I'll have a positive end and a negative end. And what I'll have on my real axis are a 1, positive 1, and a negative 1. There we go. Now, when I take the wheel, we're going to grab it at the top. And we're going to start here. And then it's not a clock, right? Is this a clock? No. So we're going to start at the top, but then since it's not a clock, we're going to go counter clockwise, right? And what does this give me over and over? Up here is I to the first power. Over here is I to the second, right? I to the third is right there. I to the fourth is right here. And we can keep going round and round. I to the fifth is right there. I to the sixth, right there. I to the seven, I to the 8, and so on. So a good thing to know about this spot is the money spot, money, meaning it's a good spot because every I to the 4m, where m is an integer, right? Anytime you have I to the fourth power, I to the 4, I to the 8, I to the 16, 40th, 400, 404, 408, 412, and so on. Whenever you have I to the fourth power, or the power that's divisible by 4, right? You can start right here as a shortcut and then count out the remainder of the way, okay? So let me show you what I mean by that in the example below. So the example we have is I to the 15th power. Now, I'm going to do I to the 12th first. I to the 12 divides it by 4 nicely, right? So I to the 12th is here. Then I to the 13th is at the top. I to the 14, I to the 15. Final answer is it can be rewritten as negative I. That's one way to think of it. What is another way to think of this, right? Well, let's pretend we didn't do that. Okay, what's another way? Instead, what if I think of this spot right here as I to the 16 power, and then I go backtrack? Okay, well, there it is again, negative I, right? What else? Another way to think of it, I use the word remainder, right? So let's divide like a fourth grader. What is 15 divided by 4 like a fourth grader? That's going to be 3 remainder 3, right? So that means it's equal to I to the 3, whatever the remainder is. So coincidentally, the remainder and the, main part of the quotient there, oops, a little squashed. The divisor the quotient and the remainderable 3. But the 3 here, let's see. Is this going to be crazy? Can you read that? You can read that. That's what we're looking at. And then that's going to be right there. Okay. So that means we have I, or negative I is the final answer. So whatever way you do this, okay, we're going to get negative I as the answer. Okay. So from the top, one last time, let's see, clean that. I'm going to do it 15 divided by 4, and that's 3 remainder 3. The remainder 3 is what I'm going to rewrite with my power. So then I'm going to have I to the third, and then that I to the, nope, that's not where I start. I to the first, I to the second, I to the third. So that becomes negative I, and that's your final answer. Okay. So do what you got to do there. Now there's other ways you could do it. Again, that I to the 4, I to the 4, just to clarify, I to the 4, that's your I to the 12 times I to the third, right? This is going to turn into 1 times 1 times 1, which who cares, right? No one cares about that. That's all 1, 1, 1 times I to the third, and then I to the third is still negative I. Okay. Not only can we break it down to show the existing I to the fourth, but I can multiply something by I to the fourth. Why am I allowed to do that? Because it's the same as doing times 1. Aren't you allowed to multiply by 1 whenever you want? You are. So that right there is going to become I. What do you do with your powers? Negative 3 plus 4. And that's I to the first. And I to the first is just I. And I is the final answer. Done. Right? You could think of it that way. Or what else could we think of it as? A lot of ways we could think of this. Maybe we think of it as 1 over I to the third, and then we are rationalizing our denominator. Now, do I have to multiply by I to the 4? No, I need an I because I want the bottom to become I to the fourth. So now the top is just I, the bottom is I to the 4, and I to the 4 on bottom is 1. Really, you can make the bottom not just I to the 4, you can make it I to the second as well because that's negative 1, but whatever, I don't want to deal with the negative. So there you go, and you get just final answer again of I. So maybe redo these a couple times, get a good idea of what's happening. It could get a little messy, but hopefully you understand what I'm saying over here. By the way, this over here breaks down, I think I did it in an earlier video already. That's why I didn't redo it, where the main 4 values come from and showing how they repeat. So if you need a little evidence, like you don't believe me, you can just follow this. But I'm pretty sure I recorded an explanation of this in an earlier video, but it might have been the video that ended up being like a corrupt file and I couldn't upload it. So if you want to see that, if I didn't upload it, I can't remember. Just let me know. But I think I did. And if not, I definitely have a video that I recorded a couple of years ago. It's on the imaginary number playlist. So I'll put both playlists on the screen right now so you have both and you can see where all that stuff comes from. All right. Check the playlist, questions, comments, give a beautiful little thumbs up for the cutest hedgehog in the world. All right. Or give a thumbs down because you hate him and his glasses. That's it for now. Adios.